Alright, so this is a recap of what we were doing in class with GeoGebra. It's the short method of differentiation. After we're comfortable with that, we'll go into differentiating from first principles. But for now, we're going to look at some of the rules for differentiation. So this is just a more formal way of writing out what we were doing in class the other day. So if y equals x to the n, so we have some function of x with a power, then when we differentiate it, y dash, we get nx to the n minus 1. So we bring the power down and we take 1 off the power. So when I differentiate y equals x to the 7, then I get y dash is equal to 7x, and then we take 1 off the power, and it's 6. Okay? Now, the second rule, if there is a constant in front of the x to the power of n, then we multiply the constant by the power. So the dy dx is just another way of writing the derivative. It means exactly the same thing as y dash. So if y equals 4x to the power of 8, then dy over dx is equal to, so we go 4 times 8, 32x, and then we still take 1 off the power. Okay? Now, if we have a function of x, so instead of writing y, they're just writing f of x, means the same thing. So if our function of x is equal to k, a constant, then when we differentiate it, we get 0. Now think about what that means. If I were to graph y is equal to some constant, then what I have is a straight horizontal line. So when I differentiate it, well, what is the gradient of that line? The gradient is 0. So that's why when I differentiate this, I get 0, because the gradient of that line is 0. All right. Now the next bit you'll see looks a little bit confusing, but really it's not. What it's saying is that if I have two functions that I am adding, and it works for subtracting as well. So if I have two functions that are being added or subtracted, then I differentiate each function. That's basically what that rule f dash x plus g dash x means. So in real terms, if I've got this f of x is equal to x to the power of 4 minus x cubed plus 5, then all I do to differentiate that function is differentiate each of the elements. So we differentiate x to the power of 4, that becomes 4x cubed. We differentiate minus x cubed, so that becomes minus 3x squared. And when we differentiate 5, we get 0. So the derivative of x to the power of 4 minus x cubed plus 5 is 4x cubed minus 3x squared. So we'll go through some examples of this now. So the question will say something like differentiate, and then it'll give you your function. So just what we were doing a moment ago. We've got 6x cubed, so we bring the 3 down, 3 6s are 18, x, and subtract 1 from the power. So the derivative, or y dash, is 18x squared. Okay, when we get a more complicated function, you just do each element. So y dash is equal to minus 4 times 3 is 12, x, take 1 off the power, plus 2 3s are 6, and then we take 1 off the power. When you differentiate 1, you get 0. Now it works whatever sorts of coefficients of x you have, whatever powers you have. So for this function, y is equal to 3/4 x minus 2. Same deal. When you differentiate x, you're left with 1, because x to 0 is 1. 1 times 3/4 just leaves me with 3/4. Which makes sense when we talked about how we write the equation of a straight line. Whatever the coefficient of x was is the gradient, and when we differentiate, we are finding the gradient function. So you should be able to do that without your differentiation rules. You should be able to tell me, well, it's written in the form y equals mx plus b, therefore m, the gradient, is 3/4. This is just confirming what we already know. All right, now something else you can be asked to do. If you're given a function, so f of x equals 3x squared plus 2x minus 4, evaluate f dash 3. So what that means is first they want you to find the gradient function because that's what the f dash means, we're differentiating. And then they want you to substitute in at 3. So they want to know what is the gradient at the point when x equals 3. Because it's a gradient function, the value of the gradient changes as we move along. So we need to find out what it is at that particular point. So it's a two-step process. The first one is just differentiating, which hopefully we're all getting really comfortable with now. So f dash x is equal to 6x plus 2. So that's your first step. After you've differentiated, then you substitute in. Whatever you do, don't try and do both things at the same time. Do the first step, do the second step, okay? So 6x, so that means 6 times 3 plus 2. So 6 3s are 18 plus the 2. So at the point x equals 3, the gradient of this function is 20. Okay, that's what you need to do exercise 8.5. Good luck, and I'll see you in class.